Hi, welcome to Gases Part 2. My name is Dr. English, and today we're going to be talking about Boyle's Law. We're going to start by looking at Boyle's Law, looking at the graph of pressure versus volume, solving for pressure and volume, and then finally a little practice at the end. So what is Boyle's Law? Boyle's Law is a pressure-volume relationship. It states that if temperature is held constant, which is very, very important, the volume of a gas is going to vary inversely with its pressure. So that means if the pressure increases, your volume will decrease. Or if your pressure decreases, then your volume will increase. And we can see that from this little graphic that we have right here. At the beginning, we have a pressure of 1 atmosphere and 10 milliliters, which gives us a constant of 10. If we cut that volume in half to 5 milliliters, we see that the pressure doubles because we still want that constant of 10, which leads us to the pressure-volume relationship. Now let's talk about graphing the pressure-volume relationship. Graphically, Boyle's Law is shown as a hyperbola based on the following equation, which is pressure times volume gives you a constant. Looking at a graph, though, we can see as volume decreases, pressure will increase over time. So now let's talk about solving for pressure and volume. Using the combined gas law from reference table T, the variable of temperature can be removed. And if we remove that variable, like temperature 1 and temperature 2, we see this inverse relationship that we're going to focus on right here, where we have a P1 and a V1, which is our initial pressure and our initial volume, and a P2 and a V2, which is our final pressure and our final volume. So let's do a practice problem. A gas at a pressure of 71 atmospheres is held in a container with a volume of 545 liters. The volume of the container is then increased to 1,065 liters without a change in temperature. This is really key right here because this tells us that we're using Boyle's Law and we can hold this particular variable constant. What is the new pressure of the gas? So the first thing that I'm always going to do is write out my gas law. So P1 V1 is equal to P2 V2. So I can tell here that my initial pressure, my P1, is this 71 atmospheres right here. So I'm going to plug it in, 71.0 atmospheres. And then my volume is 545 liters. So 545 liters. And that's going to equal P2, which is what I'm solving for here. P2. And then my V2, my second volume, is going to be this 1,065 liters. 1,065 liters. So if I multiply together the 71 times the 545 and I divide that number by 1,065, I'll end up with my final answer of P2, which is 36.3 atmospheres. And I can look at this and say that's the correct answer because this is to 3 significant figures, 3 significant figures, this is 4 significant figures, so my final answer should be to 3 significant figures. Now what I want you to do is stop, try these two, see if you can get them, come back and check your work. Welcome back. Let's see how you did. The pressure of 10 liters of a gas on the walls of a container is 258 kPa, and kPa stands for kilopascals. If the pressure is increased to 500 kPa, what would the new volume be? So again, the first thing that you always want to do is write out your equation. P1 V1 is equal to P2 V2. So the first thing that they give me is 10 liters. So that's going to be my V1. So 10 liters of my gas. And then they tell me my initial pressure is 258 kPa. So 258 kPa. Don't want to run out of room here. All right. If the pressure is increased to 500 kPa, what would the new volume be? So 500 kPa. And then I'm looking for my V2, which is my new volume. So if I multiply together 258 times 10 and I divide that number by 500, I should get 5.16 liters as my final answer. And if you think about that, that makes sense because my initial pressure is 258 kPa. My final pressure is 500 kPa. So my pressure is increasing. So my pressure is increasing. And if my pressure is increasing, because this is an indirect relationship, my volume should be decreasing. And I can see that it is because I'm going from 10 liters to 5.16 liters. So the relationship holds true here based on my results. Let's look at this final practice problem. A sample of gas has a volume of 2 liters at an unknown pressure. So it looks like we're looking for P1 here. When the volume increases to 4 liters, the pressure is found to be 0.5 atmospheres. What was the original pressure of the gas? All right, let's write out our equation. P1 V1, P2 V2. So I am going to be solving for P1. My initial volume is 2 liters. 2 liters. My volume is increasing to 4 liters, but my P2 is going to be 0.5 atmospheres. My V2 is going to be 4 liters. So 4 times 0.5 is 2 divided by 2. My initial pressure here should be 1 atmosphere. So let's look at this relationship again one more time. We determined that our P1 was 1 atmosphere and that decreased. So here my pressure was decreasing to 0.5 atmospheres, which means that my volume should be increasing. And we can see that is the case because we've gone from 2 liters to 4 liters. So again, our answer makes sense with the rest of our problem. So what did we learn in this little tutorial? We were introduced to the concept of Boyle's law. We looked at the graph of pressure versus volume. We solved for both pressure and volume. And then we did a little bit of practice at the end. Need more help? Feel free to contact me. Have a great day.